How does a cell phone achieve wireless charging? Let's start with a little experiment. This is a coil with an ammeter attached to both ends of the coil. When we insert a bar magnet into the coil, the needle of the ammeter will move to the right, and if we remove the magnet, the needle of the ammeter will move to the left. In other words, a current is generated when the magnet moves back and forth inside the coil. Since a magnetic field is generated around the magnet, according to Faraday's law of electromagnetic induction, the magnetic field changes when the magnet is moved back and forth, which causes a current to flow in the coil. As we keep moving the magnet back and forth, the direction of the current switches back and forth, and that's how alternating current is generated. And the current increases with the speed of the magnet or the number of coils. So what does this have to do with wireless charging? This is the coil inside the wireless charger, and when the current passes through the charging coil, it creates a magnetic field. This coil is equivalent to the magnet in front of it, and this yellow one is the coil inside a smartphone. If you put the smartphone coil down, the coil will have an induced current due to the change in the magnetic field. But when the phone is standing still, the magnetic field no longer changes and no current is generated. Have we been moving the smartphone back and forth like a magnet? Of course not. Since we cannot always move the phone, then we let the magnetic field actively change how to do it. First of all, household AC power through the adapter will be converted into DC power of the appropriate voltage. DC power comes to the wireless charging device will be converted into AC power. The alternating current will cause the positive and negative poles to change, which will result in the direction of the magnetic field changing as well. Due to electromagnetic induction, the cell phone coil will pick up this magnetic field and generate induced alternating current, AC, through the capacitors in the circuit. Then the alternating current through the rectifier regulator reconverted to direct current, so that the cell phone battery can be charged. In fact, the induction cooker we use in life, the principle is similar to this. There is a coil inside the induction cooker, and the coil also generates a constantly changing magnetic field through the alternating current. The question is it true that many people on the internet say that you can wirelessly charge your cell phone with an induction cooker? In fact, it is not possible. The induction cooker has the function of detecting pots and pans, and it will not work if it cannot detect pots and pans. In addition, wireless charging and induction frequency is not the same. When the resonant frequency of the charger resonance coil and the external electromagnetic wave frequency is not the same, it cannot sense enough voltage. In addition, some cell phone charging will have protocol certification, not through the charging protocol is also can't be charged, so with induction cooker to cell phone wireless charging don't easily try.